Motion under gravity. Question is, a ball is thrown upwards so that the height h in meters above the ground after t seconds is given by h of t equals to minus 5t square plus 30t plus 1, where t is greater than equal to 0. Find the ball's initial velocity. Now, velocity is rate of change of displacement. Here the displacement is along the vertical side and we are given height. So velocity is actually rate of change of height in this case, so which can be found by finding derivative of the given equation. So we get minus 10t plus 30, right? So that is the velocity. When we say initial velocity, then we are looking for velocity when t is 0. So when t is 0, we have 30 as initial velocity. The units given to us are meters per second. So meters for height and rate, which is dh dt. So time is seconds, 30 meters per second. Now part B is find the maximum height. Now maximum height will be reached at the turning point, right? So at that turning point, velocity is going to be 0. So we'll take advantage of that part and find first time and then substitute time to get maximum height. So when is velocity 0? Velocity is equals to 0 when we'll equate this equation to 0 and figure it out. So let's equate this to 0, right? So that means at t equals to 3 seconds. So this gives us t equals to 3 seconds, the velocity should be 0, correct? Now we need to find maximum height. So what is the height at t equals to 3? So let's plug it in the original equation, right? Which is minus 5 3 square plus 30 times 3 plus 1, which is 3 square is 9. So we have minus 45 and this is 90 for us plus 1. So 90 minus is 45 plus 1 gives me 46 and the units is meters. So maximum height is 46 meters. Find the velocity of the ball when it is caught 1 meter above the ground. Okay, so that means we have to find first the time when the body is 1 meter above the ground. So I'll write 1 for ht and solve for it. So we have this equation, 1 meter above the ground, that means h of t is 1, and we'll find time now, t square plus 30t plus 1. So we'll take 1 on this side, becomes minus 1, we'll solve this equation. To solve this, we can actually factor this part, right? So we can 5t common. Factoring helps to find equation solution. Now, so we took minus, so it is minus 6 inside, and 1 minus 1 was 0. So we are left with minus 5t square plus 30t, which can be factored like this, right? So we find that at t equals to 0, it could be 0, or at t equals to 6. So t equals to 0 was initial point. So t equals to 6 is the point when it is caught. Now we need to find velocity when it is caught. So that means in our velocity equation, let me number this equation as equation 2, right? This is our equation 1. So we'll substitute this in equation 2 and find velocity. So we have velocity at t equals to 6 equals to minus 10 times 6 plus 30, right? That gives us minus 30 meters per second. Minus 30 indicates that the body is moving downwards, correct? Now it's a good idea when we have done so many calculations to represent our data in the form of a figure, right? So here is kind of the diagram which can represent the whole situation. So what we found is that the height is maximum when time is 3 seconds, right? So it starts from here and we have a maximum height at t equals to 3 seconds and then hits the ground afterwards, correct? So, and it starts with 1 above. So this is kind of a figure here. So when we draw it, we get like this, right? So what happened is, if t is 0, then our height is 1 unit. So that means ball is thrown from the height of 1 meters. And it reaches a maximum height of 46 meters after 3 seconds, right? And it is caught also at the height of 1 meters when this time was 6. Do you see that? So that is how the graph is. And as far as the velocity is concerned, we found that the initial velocity is 30 meters per second. So if we have to plot velocity also. We can do it in here. Let's say approximately, the units are different, right? The velocity, so let's take another scale for velocity which has meters per second as the unit. So its initial velocity is 30 meters per second. When it reaches this point, at that time velocity will be 0, and when it reaches this point, at that time velocity will be negative. So it will be a straight line like this, which is being represented by the equation 30 minus 10t. So this point is 30 for us, and we'll write unit as meters per second, right? And this is 0. And we found that at t equals to this, it was minus 30 meters per second, right? We didn't find. So as an exercise, of course, when it hits the ground, after that it is not valid. So at this point you have to stop this graph, right? So our domain really for time is t is greater than equal to 0 but less than equals to this point, right? Which we didn't find, but you should find this. Okay, figure this out. So as an exercise, find out when the ball hits the ground so that you know the domain of your and the velocity with which it hits the ground. Okay, so let that be an extension to this question, but I hope you get the concept. The concept here is there is a movement along the vertical, and this is due to because the ball is thrown upwards against the force of gravity. It goes up and is being pulled by the force of gravity downwards. So acceleration here is because of gravity. So another part what you can find is find what is acceleration. Okay, so acceleration you can find as derivative of velocity, correct, which in this case will be minus 10, and the units will be meters per second square. In reality, acceleration is very close, which is 9.8 meters per second square, correct? So it is a real life situation, but for simpler calculations we have rounded the figure and got a round answer of minus 10 meters per second square, right? So I hope this gives you good understanding of motion under gravity. So go through it once again, and then I hope you can solve any problem on this with the help of this example. Thank you and all the best.